So you noticed in the get started activity that we have basically two options. We can factor something, or we can do the completing the square. The completing the square is always the same pattern. It's always going to be move the constant over, split the number that's attached to the x in half, square that, move it there, blah, blah, blah. So wouldn't it be nice if we could just do all of that and have a formula that isolates for x and then just plug each number in and find out what x could be? So what we're going to do is we're going to move this around so that we isolate for x in a way that we can solve it. So we're going to basically complete the square using variables instead. Then we'll have a formula that we can use for any x in any situation. First thing we want to do is get rid of this a, because I can't have anything in front of my x squared, which means I'm going to divide by a on both sides. The a here is going to get canceled out, and then we're just going to have to represent that it's still present underneath these other ones. It's still 0 over here because 0 divided by anything is just 0. Now we want to move this guy over here, so we're going to have x squared plus b over a x here, but on the other side we have negative c over a. And in this space, I'm going to cut this in half, so it's going to be, anything cut in half is just having a 2 on the denominator. So my middle term here is going to be b over 2a, and if I'm going to square that to get this term, then I'm going to end up with x squared plus b over a x plus b squared over 4a squared, because we have to square everything, equals negative c over a plus b squared over 4a squared. Now that's getting kind of yucky. So let's see, now I can write this side as x plus b over 2a all squared, and that side is kind of a mess. I can switch the order to make it a little simpler by putting the negative in between so it looks tidier like that. And if I want to actually solve this side, I'm going to have to multiply this one by 4a to get to 4a squared, so that one has to be multiplied by 4a as well. So I'm going to end up with b squared minus 4ac all over 4a squared on this side. And this side is going to be the same, but if I take the square root of each of them, then I'll have a square root of this, and all this side will say is x plus b over 2a. So it's getting a little bit crazy now. I'm going to bring this up here so that we can see it a little more clearly. So I'm left with x plus b over 2a equals the square root of b squared minus 4ac all over 4a squared. Though I'm still trying to get x all by itself. So I can make this a little easier to look at by taking any square roots that exist. So in this case, this has a perfect square root. So I could rewrite it with just the square on the top, and I have the b squared minus 4ac under the square root there, and then this whole thing is just over 2a. Oh look, there's a b over 2a here. So if I move it over to the other side, then I'm going to have minus b over 2a here, which means these guys have the same x's by itself now. but these guys have the same denominator, so I could put this negative b plus or minus the square root of b squared minus 4ac all over 2a. And it turns out that, ugly as it is and difficult as that was to go through, this is the formula that I can use to solve any quadratic equation. Why didn't I tell you about this before? Ha! You had to earn it. But now you've got it. We'll show you how that works.